So, good afternoon, everybody. Welcome to the final presentation. Yay! Final day. So today I will present a presentation from my team um, with Sungwon Park, Nathan Lee, and myself. So presentation. The project survey is about potential of water temperature difference for energy purposes. So today we'll mainly speak about competitivity. How can this technology can be competitive compared to other technology? And in order to increase the competitivity, we will speak about three aspects. One is the cost optimization. Second is increase the efficiency, and the third one is hybrid systems. But first, let me remind you of our goal from proposal. We already spoke about the feasibility study and requirement to produce energy out of water temperature difference. We also already speak about the different hot and cold sources, and as I say, today we'll compare to similar technology and also try to combine multiple ways to raise the efficiency. So let me refresh you what is our project about really quickly. So our project is about OTEC. OTEC is Ocean Thermal Energy Conversion. It's a way to produce energy out of temperature difference, and it has a really huge potential. You can read it here, up to 88,000 terawatt hour per year, where the world electricity generation is today, 2014 is 24,000 terawatt hour per year. So more than enough. It's really huge potential, and it's even greater than all other ocean energy resource options. I have also a video, I don't know how to. The video, we already watched it in class, I think. So, sorry. This is a really schematical way of presenting this technology, but the working principle is really easy. So, here you can see we take the deep water temperature about 1,000 meters deep, which is about 4 degrees Celsius. And also, as a hot source, we took the surface temperature, which is about 25 degrees Celsius. And in order to produce energy, we need the thermodynamic cycle, which is here. So we pump the water in the cycle, and here are two heat exchanger. So we heat the working fluid, and here, for example, it's ammonia, but it can be many working fluid. And then we send it to the turbine, produce electricity, and then cool it with the condenser from the deep water. And then reheat it with the surface temperature. Here should be a condenser that is missing. Yeah. So, as I said, condense ammonia and then evaporate, and then produce electricity with the turbine. So that's it for the concept. So, competitivity. As I said, it will be the main subject of today. We already compare different technology. This comes from last presentation, the midterm presentation. So I won't go through deeply. Just remember that for OTEC, we have really large potential, no carbon footprint, continuous energy generation. I will come to it later. Yeah. So we already talked about this in last presentation. But what does it mean in terms of economics? So here is the plot. We can see that OTEC is really expensive. This is the dollar per kilowatt hour, like dollar per energy, per electricity. OTEC is really expensive, like 18 cents per kilowatt hour, compared to the other renewable energy. And the main competitor are here offshore wind and solar photovoltaic. So it will be great for OTEC to reduce the cost until 0.1 around here, like to be in the range of these two. So that will be our goal later. And also, I speak as OTEC is a continuous form of energy. That means we can, every time, day and night, produce electricity out of OTEC. And this is really special, really unique advantage of OTEC. You see here the capacity factor. Capacity factor is how long can the plant work at full power. And you see it's about every time for OTEC in comparison to solar power and offshore wind, where, as you know, there is no sun during the night. There is not always wind, so the capacity factor is much lower. On this axis is once again the cost. So we need to improve the competitivity of OTEC, and for this we have three options: cost optimization, increase of efficiency, and hybrid system. So let's talk about the first, cost optimization. Similarly to offshore power, offshore plant, there is like every project, OTEC project should be unique. It has unique cost and debt profile. Every project has different environmental conditions and also seabed condition, are most important the size. And because of this, the engineers of the project should really think about the design in order to reduce and optimize the cost of the plant. And there are some choices they can make. For example, should we build the power plant onshore or offshore? In the video it was offshore, but if we choose an onshore way, then here you can see the cost. For example, onshore will reduce the energy transfer because the energy is already on the land, so it will reduce the green part, but it will probably increase the water ducting because we need to take water from further away. So this blue part will increase. And you can see here that the biggest cost of OTEC is the heat exchangers. And this is because the temperature difference is pretty small, so we need really huge heat exchanger. The second way is to increase the efficiency. So I don't know who of you took a thermodynamic course. Are you familiar with this, more or less? So I say the efficiency of a plant is the total efficiency is composed of the theoretical, like thermodynamic efficiency, which is defined like this. for an ideal case. And because because it's impossible to reach the ideal case, we always have a loss. And so these two together give the total efficiency. So for today, the today case, we saw that it was 18 cents per kilowatt hour, which give a total efficiency of 3%, which is really, really low. And the theoretical efficiency, this one, because of the temperature, delta T 25 degrees, only 7%. And to reach this goal of 10 cents per kilowatt hour, we need a total efficiency of 5.5%. And to reach this, there is two ways. We can increase this part, the loss. And to reduce this part, we need better technology, so we can not do much about this. Maybe just wait for better technology. But we can try to increase this. And to increase this, we need to increase the temperature difference. So to reach our goal, we need a theoretical, like this efficiency of 12.5 degrees, which corresponds to a temperature difference from 35 to 40 degrees. Is it doable? We already spoke about the SIT analysis, so I will briefly go through this again. So this is normal case. It's not enough. Hydrothermal one will be more than enough, but as we already talked about, it's really difficult to achieve because of extreme conditions and really local sites. Thermal line circulation is good, but not big enough. Arctic areas will be just good, but as we talk about it, it's also really difficult to achieve. And the waste out of power plant is also not enough. So to summarize, to conclude this topic, it will be great to be able to increase the efficiency, but it's really difficult to have different household sources because either it's not enough, as we just talked about, or it's difficult to achieve. And we can think about new ideas like solar boosted way, which is like just before sending the hot sources, we can heat it more with solar concentration, for example, which will increase the temperature and increase the efficiency. So it's a good beginning, but it might not be enough to be competitive. Good. One big advantage of OTEC technology is that we can have hybrid system, which means we can, apart of electricity, we can also produce other way to make money, like to be economic. One of these is desalination. The other is production of hydrogen. The third one is air conditioning and chilled soil agriculture. And the last one is aquaculture. So first one, desalination. Really easy. We need to evaporate seawater and condense it later. So that's the working principle. And in order to achieve this, in OTEC, we need a open cycle, which means taking directly the water to produce as working fluid, like evaporate the water directly and not using working fluid. So these are a hybrid combination. And some studies show that it can reduce the electricity cost of around 1/3. And more than that, we can also produce salt. We can also make this a business. But is there a market for desalination? Yes, of course, there is high demand, especially in the area where OTEC can operate, which is around the tropical area where there is a lot of developing country that need water. And also until now, the desalination is really energy intensive. It corresponds to 0.4 of the global energy consumption, 0.4%, sorry. And usually it's not sustainable, meaning it uses fossil resources in order to desalinate water. The second one is hydrogen. The principle is really easy. It's to use the power or part of the power produced by OTEC to produce hydrogen, to separate water into hydrogen and oxygen using electrolysis. And one big advantage of OTEC is that it already uses cold water, so it's easier to liquefy the hydrogen, and also oxygen if it's economic. But oxygen for now is much less economic than hydrogen. And also OTEC are located offshore or near the shore, which make really easy for the shuttle tanker to go back and forth. Is there a market for hydrogen? Yes, again, we need to find a new fuel to replace petroleum, and hydrogen is really efficient and does not pollute. And also currently the hydrogen production is from fossil resources. So it will be a great alternative to use OTEC for hydrogen. And more than that, with hydrogen, we can produce ammonia fertilizer, which can contribute to the food production in the country that use OTEC. One of the problems of hydrogen is the storage. So now air conditioning and chilled soil agriculture. So OTEC, as we saw, use cold deep ocean water, and this water cool or act as the cold resources, so it will a bit warmer during the process, but still it will be cold. And we can use the remaining cold water to cool the industries and homes, and this can produce additional income for OTEC. And also we can send the cold water into underground pipes to chill the soil, and this make new opportunities to grow up new species in the tropical zone, which correspond to new business opportunities as well. And finally, aquaculture. Deep ocean water have a lot of nutrients compared to surface water, and we can use this as a fertilizer to grow up algae or fishes. And again, we have cold water, so we can grow up, for example, fishes that are used to live in colder water than tropical zone. And this also creates new business opportunities. And more than that, we can, oh sorry, what did I do? And more than that, we can use the cold water to have a low-cost refrigeration, which is really useful for fishes. So maybe before this, to conclude, we saw 3 ways to increase the competitivity is the cost optimization, increase the efficiency, and hybrid system. Maybe separately, it's not enough to have a competitive OTEC, but if we combine the 3 together, it's highly probable that we can have a really competitive product at the end. So the goal progress, now we spoke about everything, which is good. And yeah, schedule and job allocation has not changed. It's the same job allocation. Our references. Yeah, thank you.